models and an improved use of the observations in the models. Once we do that, we're confident, or we hope at least, that our developments will aid in the formulation and testing of new theories of tropical cyclone evolution and ultimately lead to better understanding and better prediction. That's all I've got. Thank you very much.
Thank you. Maybe one or two short questions. Yes, please.
Yeah, I have two questions. The first question is, you have a lot of activity in the development of model. How do you compare your activity with those at the NCAR? That's the first question. The second question is that in Taiwan, many people use wool developed at the NCAR. Do you suggest that we should move from the wool to your model?
Okay, so the first question was, to what extent is our model development activities paralleling what's happening at NCAR, I guess is what you're saying?
Yeah.
Well, so there are many different versions, well, there's two primary different versions, I'm not going to go back, of the WRF model. The one that NCAR runs is the one that is freely available to the public. It has been for many years. And as a result, there are many people that are using that model. It's certainly a very good model. It's well-tested model. What NOAA uses is a slightly different version of the WRF model, which is based on a different dynamical core. But it's the model that we use in operations. I think there are many reasons for why the decision was made to go with that model versus the NCAR version of the model, and I'm not going to get into that because I wasn't a part of that decision. But it is a model that we think shows some potential in terms of better track forecasts and hopefully intensity forecasts. I guess what I would say is that I kind of view it in sort of an ensemble framework, that I think it's valuable to continue efforts with both models. And really what we're trying to do at HRD is just to spin up the usage of the NOAA version of the WRF model to complement the efforts that people in the research community and the academic community are doing with the NCAR version of the WRF model. So I would argue that it's very important to continue doing what we're doing with the NCAR version of the WRF, but it's also just as important to develop the activities that we're doing with the NOAA version of the WRF model to really complement what's happening with the other model. I don't know, that almost maybe answers your second question too, I hope.
Okay.
Well, on your first slide, you said you're going to decrease the track errors by 50%.
Okay.
Or then I've heard it explained, well, you're going to decrease the hurricane impacts area by 50%.
Okay.
Which one is it? And what do you think is the limit of predictability of track forecasting?
Okay, so I think I can't really answer definitively your first question. I would say that probably what we meant was track forecast, because I don't know how you define. Actually, let me show you. I have it as a supplemental slide, I think. In terms of the impact area. Sorry. Silly thing. All right. Okay, here's an example. So here's an example of a track forecast, and our goal is, I think what you're talking about in terms of impact area has to do with forecast uncertainty, really. So there's two different questions there. There's the track forecast itself, which is where you actually think the center of the storm is going to go, which there's some issues about whether or not you should even worry about the center of the storm and not just the swath of the winds, for example. But there's also the uncertainty, and the uncertainty really comes into play in terms of the impact area. This really illustrates that issue nicely. Here's an example of a forecast from an operational forecast from the Hurricane Center for Hurricane Wilma from 2005. So again, this solid line and the dashed line is where they think the center of the storm is going to go. But then if you can see, this cone is where they think the center could possibly go. So really, in a way, this cone represents the forecast, the track forecast of uncertainty. And you could argue also the structure of uncertainty, but I don't think the Hurricane Center thinks about that anymore. So the hope is that by at least quantifying and bounding our uncertainties and hopefully reducing those uncertainties, that would lead to a smaller impact area. So again, if you look at the width of the cone, if we could realize a 50% reduction in our uncertainties, or 50% improvement in our uncertainty, that would result in, for example, in a much narrower swath as far as what we're getting in this case. So does that make sense? And then your other question was, well, what do I see as a predictability limit for track forecasting? I I don't know a number for that, but I'll tell you that it's certainly, I would say it's more predictable than intensity forecasting. So I don't think we've reached it yet, and I think there's still worthwhile investments that can go toward especially global model developments and ensemble forecasting schemes, for example, to improve our track forecast and reduce our uncertainty. So I think there's still a lot of progress that can be made on track forecasting, but at the same time, we need to also look at intensity and structure forecasting as well.
My time was sent for the next question.
I just have a very quick comment in that we have all this data and it's all available on HRD's website now, back to the 1970s, and we're going to try to make it easier for everybody to get. So if you're interested in any of these data that we have, you can go to our website or ask Rob or me for show you how to get to the data. And we welcome collaborations and everybody to use the data and learn more about hurricanes and typhoons.
Thank you. I think because it's a little bit late, so we should. Thank you.
Thank you.